Hello everyone. First of all, thank you for showing interest in our webinar. I am Gomati Shankar, Product Manager for the NVIDIA camera add-ons ECAM 130 CU-TX1 and ECAM 30 CU-TX1 from econ systems. And I have my colleague Dilip Kumar, camera specialist, along with me to give you more insights about Jetson camera interface. So the following is the agenda for the day. First, introduction about econ. Many of you may know about us already. In any case, I start with a small introduction about econ systems and its camera expertise for the first 5 minutes. Next, we'll see what NVIDIA TX1 and TX2 offers for imaging and cameras. We all know how powerful the TX1 and TX2 are. These are the most powerful and most power efficient embedded computer available today. Combined with the camera capability, it's proving to be a potent combination. We will explore about this for roughly 20 minutes. Then thirdly, we'll take you through econ systems camera for NVIDIA TX1, TX2. Econ systems has developed off-the-shelf cameras for Jetson TX1, TX2. You might have seen that in our website already. We also have some YouTube links available. We'll show you how you can easily start working with the TX1, TX2 cameras with econ systems camera and also with our software, I mean the driver application and the whole ecosystem. This will be for around 10 minutes. Then we'll have our some demo about the cameras. We already have a 13 megapixel demo available, and also we have a 6 camera synchronized 6 camera solution available. Unfortunately, we will not be able to show you the video over the webinar. Unfortunately, we will not be able to show you the video or the webinar, so we will provide you a YouTube link over the chat, and also we have some screenshots for you to have a look. Having covered what NVIDIA has got in TX1, TX2 for cameras, what econ systems offers in terms of development boards, then you will listen to Dilip listing out the various use cases, things you can do with the powerful NVIDIA processors along with our cameras. Believe me, it's endless possibilities. Then finally, we will end up with some QA session. We'll have around 10 minutes for the QA session. Hope you are clear. To introduce, we are Econ Systems, your embedded development partner. We founded in 2003. We have more than 14 years of embedded product development experience, and our vision is to provide product building blocks for your product development. We have more than 225 engineers who are mainly focused on embedded product development. And about our partners, for long we have partnered with sensor partners on Semiconductor and OmniVision. We are also partnering with Sony this year. We are coming up with Sony cameras as well, which will support which will be obviously supported on NVIDIA Jetson TX1 and TX2. Cypress is our USB partner. We are Cypress silver level partner. We design and sell their USB FX3 and CX3 dev kits. And our FPGA partner is Xilinx. And on the CPU GPU side, we have NVIDIA. We are a recognized NVIDIA scaling partner. Since we are NVIDIA scaling partner, we have complete access to the NVIDIA TX1 TX2 ISP. We can interface any camera sensor to the NVIDIA TX1 TX2, and we can also do performance fine tuning. We have been doing this for many years. We have been working with many ISP, and we are too good at that. We can take best out of it. We are also working closely with the NVIDIA core development team, so we can get best out of NVIDIA platforms. Though we already have off-the-shelf cameras for Jetson, we are open for customization as well. Customization in the sense we can do hardware and software customization for your product. Econ systems, we used to call ourselves as one-stop solution. If you are looking for a solution with a camera and a processor in any embedded platform, we will be able to provide that. To start with, you can buy our off-the-shelf camera from our online web store. You can evaluate it and make sure the performance works for you, for your application. And then we are open to do hardware and software customization for you. We also have a specialist in camera imaging and vision algorithms. So they can help you in product development, any kind of algorithms related to cameras. We'll be able to support you. And we have our own manufacturing facility here. So for your mass production, we should be able to help you. These are the main two camera divisions we have. One on the USB. We have off-the-shelf USB 3.0, 2.0 cameras. All our USB cameras are UVC compliant, so you don't need to worry about drivers. You can just plug and play. You don't have to plug and pray. And another division who is mainly focused on embedded cameras. It's basically a MIPI interface cameras, parallel interface cameras. We support many platforms. And these are our USB 3.0 camera module portfolio. You can see many USB 3.0 cameras. We also support MIPI camera in all those modules. To start with, I'll start from the left. We call these modules as C3Cam modules. It's a 3.0 camera modules. To start with, C3Cam CU130. It's a 13 megapixel camera based on Aptina AR1335 sensor. It can support both OUV and MJPEG. You can stream Ultra HD video at 30 FPS. And this is an autofocus camera, small form factor autofocus camera. It can fit into any small embedded device. And then the C3Cam 81. It's an 8 megapixel camera which can stream HD at 30 FPS. Then C3Cam CU130, which is based on AR1820. It's famous for its pixel size. It has a big pixel size, so you can have more clarity in the pictures. And then one of the popular cameras we have is C3Cam CU50, which is cost-effective cameras. Then Then we also support infrared camera modules, which can be used for iris recognition and also for face detection. For those kind of algorithms, we should be able to support. Also, the Freecam CU30. It's a low light camera. You can stream video and images even at 1 lux. The picture quality of these cameras are really great. It comes with both custom lens and also with autofocus support. For autofocus, we use liquid lens. So with the liquid lens, you can have wider FOV. Then the monochrome camera CU51. Also, we support global shutter cameras. Then we are coming up with a 2 megapixel camera, C3 CU20, within a couple of months, which can support wide dynamic range. We are also coming up with a camera with a TO sensor. And this is one of our specialty cameras, stereo camera. Comes up with USB 3.0 interface, which can be used for depth detection. You can measure depth in 1 millimeter precise from 50 centimeter to 300 centimeter. It's an off-the-shelf camera. You don't need to calibrate anything. You can just plug in and use it for depth measurement. So now the interesting part, the NVIDIA Jetson TX1, TX2 camera interface and cameras we support. I'll give the session to Mr. Dilip.
Hello everyone, I am Dilip Kumar and I've been working on NVIDIA processor for several years, and I started with the TK1 and then worked on the TX1, and currently I'm working on the TX2, and I specialize in camera and imaging sensors for the Jetson platforms. In the forthcoming slides, I'll explain about the camera pipeline in the TX1 and TX2 platforms, as well as the features that they support. I'll also walk you guys through the econ camera solution for the TX1 and TX2, while also explaining in detail about the customization options that we also support. We'll have a look into some of the typical use cases for these cameras as well in the forthcoming slides. You can type in your questions as I speak, and I'll try to answer all your questions at the end of the presentation during the Q&A session. So this is the top level block diagram of the camera pipeline in the TX1 and TX2 computer-on modules. It consists of mainly three major elements, which are the CSI, the camera serial interface, also called as the CSI, the video input block or the VI, and the memory interface. I'll take you through each of these blocks in detail in the following slide. So, about the CSI interface, there are three CSI blocks in the NVIDIA TX1 and TX2 SoC. Each of these CSI blocks consists of dual two-lane CSI bits or receivers, as NVIDIA would like to call it. The CSI blocks are in fact MIPI CSI-2 compliant receivers in both the TX1 and TX2. So any MIPI CSI-2 compliant transmitter, such as an imaging processor, imaging sensor, can be connected to this interface for feeding data into the TX1 or TX2 processor. The MIPI receiver in TX2 is actually more advanced compared to the receiver in TX1. It can support both D5 as well as C5 mode of operation as compared to the CSI block in TX1. It can operate only in D5 mode. The C5 mode of operation can support more advanced sensors and higher throughputs than the D5. So next we will see about the CSI configurations that are supported in both the TX1 as well as TX2. Each CSI brick in the NVIDIA SoC can operate separately in two-lane mode, or two of these bricks can be combined together to be operated as a single four-lane mode. The four-lane mode actually supports more bandwidth, which is in fact double the bandwidth compared to the two-lane mode. So you can opt for four-lane mode if higher frame rates are required for your application. Let's see about the bandwidth that is supported in both the TX1 as well as the TX2 MIPI interface. The TX1 as well as the TX2 can support up to 6 cameras when operating in two-lane mode, whereas up to 3 cameras can be supported when working in four-lane mode. This table should give you some idea about the frame rates achieved when different CSI configurations are used in TX1 and TX2. So according to the NVIDIA spec sheet, the maximum bandwidth that can be supported in the TX1 while using in the D5 mode is 18 Gbps, whereas in the TX2, which uses a better D5, which uses a more MIPI compliant chip, so the bandwidth that is supported is 30 Gbps. And in the TX2, it also supports C5 mode of operation, which actually supports up to 41 Gbps. So some values we have mentioned in this table will give you more information about the frame rate that you can achieve using this TX1 or TX2 processor. So you can achieve up to 120 FPS in Full HD when streaming in YEV422 in the TX2 in two-lane mode. These are all using assumptions such as 25% overhead for blanking period. Theoretically speaking, you can actually get better performance compared to this. So next we'll see about the video input subsystem in the TX1 and TX2 processors. This block is actually the core of the camera pipeline stack in the TX1 or TX2. The data from the CSI units are transferred to the video input via dedicated pixel passers and FIFOs implemented between them in the hardware. Up to 6 pixel passers are supported in parallel in both TX1 and TX2. So essentially speaking, the VI unit actually acts as a bridge for the data between the CSI and the memory interface. So these are all the subblocks that are present inside the camera pipeline of the TX1 and TX2. Next we'll see about the product that we have developed for the TX1 and TX2. So this is the ECAM 130 CU-TX1. So it works on both TX1 as well as Jetson TX1 as well as TX2. So this is actually a MIPI CSI-2 compliant camera which econ has developed specifically for the Jetson TX1 and Jetson TX2. It uses the AR1820 image sensor from onsemi and a dedicated ISP for streaming the camera images. The default lens that is provided with this camera has a diagonal field of view of 82 degrees and the back focal length of 3.62 mm. Other lenses can also be used with this camera based on the requirement. It actually uses the 4-lane MIPI interface on the TX1 or TX2 for data transfer, while controlling the camera can be done using the hardware I2C. So now we'll look into some of the features and controls that are supported in this camera. This camera supports up to supports a maximum image size of 4224 pixels wide and 3156 pixels in height. This camera also supports streaming Ultra HD video at 30 fps in YUV422 format. Of course, other resolutions such as Full HD, VGA are also supported. Any user application can actually access the camera frames using standard V4L2 APIs. We have designed the driver in such a way that any V4L2 application can access this camera. And we have also added support for standard controls such as brightness, contrast, hue, saturation, sharpness, etc. are supported. All these supported features will actually be present in the datasheet. These are just a few of the sample features that are present. So this block diagram represents the software stack for accessing the camera from the application. ECON provides the camera hardware, the sensor driver for the camera, as well as a sample application for accessing and viewing the camera frames. This sample application can be used to test all the features of the camera by simply using the GUI. The customers can use this application or any other V4L2 based application such as GStreamer or OpenCV for accessing the camera data. GStreamer is a versatile multimedia framework which can be used to support other features such as hardware accelerated encoder, which is present in the TX1 or TX2. So these are some of the screenshots of the sample application that we have developed for this camera. Unfortunately, we are not able to share the video of our sample application through this webinar. So the screenshots should suffice for now. And we also have provided the link for the video in this presentation. We'll share them with you later. One of the customization options that we provide for this camera is the liquid lens support. This liquid lens can be used to support auto or manual focus feature in the camera. The ECAM 130 CU TX1 has support for auto white balance and auto exposure by default. So with the addition of this lens, the complete 3A features can be supported. The diagonal field of view of this lens is 80 degree and the back focal length is 4.67 mm. Another customization that we provide for this camera is the support for multiple cameras. So we can provide a customized solution to support multiple cameras on both Jetson TX1 as well as the Jetson TX2. We have an off-the-shelf camera solution for the Jetson TX1 and TX2 which supports up to 6 cameras to work in parallel. This should, must be present in our web store already. We can also support synchronization between all the individual cameras through our unique hardware design. We also provide an optimized GStreamer based application for streaming the cameras and saving the images with synchronization enabled. And these are some of the screenshots of the application that was working for this 6-cam camera. Unfortunately, the video is not available for that as well, but we have the link to see the video below. So as you can see in the screenshot, so the first image shows the 6-camera setup that we have connected. The orientation of the cameras can be changed as we please. So in the third screenshot, you can see that the images are streaming in sync. All the frames are in sync from the camera because due to our hardware design, the application processor does not have to take care of any synchronization. And in the last screenshot, you can see that the CPU usage while streaming the camera to the preview to the display actually uses very low CPU usage, up to around 20 to 30% is only used. So we also provide other customizations for the TX1 or TX2 cameras. We can re-engineer the hardware to support flexible flat cables, which enables the camera to be used at a distance from the SoC, which you already saw for the 6 camera application. We can also provide driver customization to change the list of supported resolutions and frame rates. We can also provide additional image quality tuning based on the choice of lens that the customer has selected. And one another unique feature in this camera is the support for face detection and smile detection. So if the customer requires that, we can support that too. Other formats, other imaging formats such as RGBA, RGB 565, 5555, and JPEG can also be supported using this MIPI camera, because we have an onboard ISP which can do all the processing without offloading anything to the GPU. Sorry, the CPU in the TX1. So this image should show you the difference in output of the camera when face detection and smile detection are enabled or disabled. When these features are enabled, the detected face are overlaid with square boxes, and the level of smile detected on the faces is shown as a small progress bar right next to the box, as you can see in the image on the right. So you saw about our camera solution for the TX1 and TX2, and what are all the features and customizations that we supported. So here are some of the list. Here is a list of the sample use cases that we believe that this camera solution for the TX1 and TX2 will be more suitable for. When somebody is planning for an action camera which can record up to 360-degree videos, sure, you can go ahead and use our 6 camera solution. If it is a vision aided robot where stereo camera is required, you can design one for you. And if it is an autonomous vehicle, you will be requiring multiple cameras to see the different views of the camera at different angles. Their multiple camera solution, such as the 6 camera solution, will be apt for you. And surveillance drones can also be created using the TX1 or TX2 processor and using our imaging sensors. A special use case which arises due to the use of TX1 and TX2 is deep neural networks for image processing. With NVIDIA's high quality support for using neural networks on the TX1 and TX2 platforms, you can use our cameras along with NVIDIA's software solution and create your own neural network for depending upon your application. For example, if you are trying to detect cancer cells based on the images from the camera, this should be the apt solution for you. Of course, you can think of more other examples. So this is one that just came to my mind. Okay, so this is one of our latest offering for the TX1 or TX2, which is a 3.4 megapixel camera. We call it the ECAM 30 CU TX1. It works on both TX1 as well as the TX2 because both of them are pin-to-pin compatible. This camera actually consists of two parts, which is the actual camera module, which outputs the MIPI data, and the another one is the adapter board for the TX1 and TX2. So this camera can be directly plugged into the Jetson TX1 and TX2, similar to the ECAM 130 CU TX1. This camera also utilizes the 4-lane MIPI CSI-2 interface for data streaming and uses the I2C interface for camera controls. And soon we are planning for launching our first camera module based on Sony imaging sensors, which is the IMX 290 as well as the IMX 274 sensors. They are actually Starvis sensors, which support very good low light performance, and sure, you can get some great performance from these sensors when integrated with the TX1 as well as TX2. We'll be providing full support for this sensors with the NVIDIA ISP as well. This should conclude our presentation for the day, and we can proceed to the question and answer session. So we'll look into the list of questions that you have posted to us, and we'll try to answer each one of them.
Okay, we have got our first question. Is our 6 camera solution is pixel sync or frame sync? It's a frame sync.
So for this question, the cameras are actually frame synchronized because we use our own hardware and the ISP for synchronizing the cameras in the hardware level itself. So one question that we have received is how to control the sensor settings via I2C bus in OV46i2, specific to OV46i2. Okay, so to answer your question, it doesn't apply to any specific sensor, but it is general to all sensors. We provide the driver for interfacing the camera to the processor, and the driver will communicate to the sensor via I2C protocol. So all you have to do is use the camera application using V4L2 APIs for streaming the data. So you don't have to worry about the I2C part. So another question that we have received is, will stereo cam be available for the Jetson? So currently we are still thinking about implementing a stereo camera for the Jetson. But if you have a specific requirement, you can please send your requirement to econ, and we can collaborate with you and develop a solution that will be more apt for your requirement. So another question that we have received is, are the USB cameras compatible with the Jetson TX1 or TX2? And yes, sure, you can use the TX1, USB cameras that we provide with the Jetson TX1 and TX2. Not all the cameras will be fully compatible with the TX1 or TX2 because of the USB 3 limitation which is present on the TX1 or TX2. This is actually a host controller side limitation. So if you have any problems with any of our USB cameras, you can contact us through our support site and we'll provide a customized firmware so that it will work on the Jetson TX1 and TX2.
Basically, you can connect all our USB cameras in TX1 and TX2. The only difference is you may get lesser frame rate compared to when you connect these USB cameras on the PC, but definitely it will work because it's a standard UVC camera.
One other question that we have received is requesting if the ECAM 130 CU-TX1 will support infrared from the camera. So the camera, we do not support IR illumination for that particular sensor because we are using an IR cut filter on the lens that is used for that sensor. But if IR is the requirement for you, we can provide other sensors such as OV46A2 or the one used in Freecam CU12 NAR, or you can use the CU30, which is also a low light camera, and the MIPI solution is also available for that.
On the CU30 camera, you can have a lens without the IR cut filter, and you can use it for IR.
Another question is what is the API for synchronization when using V4L2? For example, when writing a C++ based OpenCV application. Yes, sure, that is a good question, and we have implemented custom V4L2 controls for that particular use case, because this synchronization option is not present in the V4L2 standard by default, and this will be enumerated from our camera driver. So you'll just have to call it like any standard V4L2 CID, and you can control or enable or disable this frame synchronization option from your application.
Another question, depth camera that works with Jetson TX1 platform, TX1, TX2 platform. You can use our Terra, which comes with the USB 3.0 interface that can be connected to the Jetson USB 3.0 interface, and we provide algorithms support on top of it. You can use that. Another question, when can we expect Sony sensor support? We are planning to release Sony sensor support Q3 of this year. The demo videos, video links will be sent over email to you. Also, we'll upload our webinar video in our website, and also you'll get a link for viewing that.
One question from another user. Does the stock kernel distributed with the Jetson development kit has the V4L2 driver bundled? And to answer that question, the V4L2 driver for the sensor will not be present from the in the default release package, because it has been developed by econ and it contains the camera settings for our camera. So you'll have to get that from us only. So this is not available in the default release package. So what is the maximum length for the CSI cables that is supported by econ's cameras? And to answer that, we can support up to 30 centimeter for length for the cameras in the TX1 and TX2.
By default, with the flex cable, you can go up to 30 centimeter, but with customization, we can go longer than that. If you wanted to have a camera at 1 meter or 2 meter distance, we should be able to do with customization.
Someone has mentioned that the Terra camera that they are using is not working with the Jetson TX1. I'm very sorry for your inconvenience. So you can contact our support website, and they'll be happy to help you get it working as soon as possible. So are these cameras also ROS supported is another question. To answer this, the cameras are not really we have not tested whether it works with ROS environment or not. But basically, if the ROS has proper support for V4L2, and if it is a USB camera, it should have support for UVC as well. Then it should work. The camera should work fine. Is there any interface for multiple USB 3 cameras to connect to Jetson TX1 on different buses? So for when customers require to use multiple USB cameras on the TX1, they can use a powered USB 3 hub for interfacing those cameras, because the power requirement for multiple cameras might exceed the power that can be delivered through the USB 3 port on the Jetson TX1. So it is recommended to use a powered hub.
But obviously, when you connect more than one USB camera, you'll get very less frame rate. Since we have more than one camera interface, we can use MIPI camera instead. If you are looking for a long distance camera, that can be customized.
One other question that we have received is, are these cameras line scan cameras? No, these are all rolling shutter cameras that we have developed, but we can also provide a global shutter solution for the cameras as well.
We still have some time. If you have more questions, please let us know.
Another question we have received about the Terra camera. Is this camera used in Terra measuring the distance from the object using time of flight measurements, or just normal cameras and generating 3D scenes using algorithms? The answer for that is these are just normal cameras, but they have pixel synchronization option, which is not present for any normal cameras. They are specifically designed to be used as a stereo camera, but the 3D scenes are generated using algorithms on the onboard, on the CPU side. The camera does not output any depth measurement, but they can be generated from the application. So another question is that what are all the sensors that are supported in the 6 camera setup that we have? Currently we have support for AR1820 camera module as well as the AR0330 module, which are actually the 13 megapixel and the 3 megapixel sensors. So these are what we have readily available right now, and if any other sensors are required, we can do that as well. You can please contact us through our web email, camerasolutions@econsystems.com.
Thank you, everyone. We are closing this session. Please let us know if you are looking for any of these solutions. Don't hesitate to contact us. You can either contact us through sales@econ systems. You can also contact us through camera solutions at econsystems.com. Or also you can purchase these cameras from our website, web store. These are one of this is the first webinar on TX1, TX2. We are going to come up with more webinars in coming days. Thank you, everyone. Thanks for your support. Have a good day. Bye.